Hear about air pollution in New York City. The professor is Professor Bostick, and our presenter is Daryush Nourbaha. Daryush, are you on?
Yeah, I'm
Great.
here. I can't
Excellent.
share the screen quite yet, but I am here.
Okay. Just a second. There you go. Great.
All right. I'm going to speak softly tonight because I have a teething 5-month-old trying to sleep very close by. So bear with me. It's with great enthusiasm that I will be sharing some of our research and findings for our capstone, which was about a very universal issue, air pollution, specifically the variation in fine particulate matter known as PM 2.5 from neighborhood to neighborhood in New York City. So here is our illustrious group. I'm the guy in the bottom left-hand corner, and our star quarterback, the eminent Dr. Ben Bostick, off to the right. All right, so let's talk about fine particulate matter. PM 2.5 is defined by its very small size, less than 2.5 microns in diameter, which is less than 1/30th the diameter of human hair. We all know pollution is bad, and PM 2.5, because it is so small, can get into our bloodstream, and it really attacks the entire body. Air pollution is responsible for about 7 million deaths per year throughout the world. These conditions are associated with both outdoor and indoor air pollution, and children are disproportionately affected by air quality, tragically making up most of these air quality mortalities. To get a better sense of how air pollution impacts children in the city, we needed to measure the air quality both indoor and outdoor. And what better place to do this than where children spend the bulk of their time, in schools. In fact, in this picture right here, Dr. Ben Bostick's daughter is actually in the top right corner. So now for our project, a big hurdle to get over was the lack of existing data. A figure to the right is the New York State Department of Environmental Conservation map of air monitoring sites throughout the 5 boroughs. There are 18 air monitors to quantify more than 300 square miles. And while there are other networks that have produced great data, what we really need is a very dense network that continuously measures. The gold standard from an air monitoring standpoint would be to have a very dense network of low-cost sensors. The New York City public school system has over 1,700 schools, with the average distance between 2 schools being less than 1 kilometer. This is the type of density we need, and the low cost of these purple air sensors make it a realistic possibility. Not only would this provide adequate data to explain citywide air pollution variability, both indoor and outdoor, but the data would also be accessible to classrooms for teaching and student empowerment. On any given day, 20% of Americans are in school. COVID permitting. That translates to about 58 million students and over 7 million faculty and staff. The air quality that these students are exposed to can impact their physical, mental, and social health, which in turn can drive up absenteeism and make students suffer from poor work performance. This image on the right is of a purple air sensor we installed inside of a classroom at the Bronx Center for Science and Mathematics. Purple air sensors use 2 optical sensors to detect an approximate estimate of fine particulate matter in the air. So how can we add to the air quality measurements that are made sparsely across the city to better understand how air quality affects children? This was the question we sought to answer in our capstone, and we partnered with the New York City Outward Bound schools to at least begin to answer this question. The schools we partner with throughout the city are listed right here in the bullets. We installed a total of 11 sensors and have some interesting findings to show you in a couple of slides. First, let's cover the methodology. So we use the aforementioned purple air sensors to measure what's in the air, both indoors and outdoors. We wanted to answer some key questions about air quality, starting with how do we make sure that these low-cost sensors are producing accurate measurements? We also asked, how does the air pollution vary from neighborhood to neighborhood? Who lives in these neighborhoods in terms of demographic, health, and socioeconomic factors? Are there any correlations between these various data sets? And how does the outdoor air pollution relate to the air quality indoors? Which brings me to the right side of the screen. To understand indoor air pollution better, we conducted a series of experiments using various sensors to track carbon dioxide. We looked at carbon dioxide, CO2, to understand how air is exchanging between the outdoors and indoors. We also conducted some indoor modeling of CO2 using some software. So here are the 5 schools in which we installed the purple air sensors. The high school I graduated from, this is very important, is Curtis High School in Staten Island, is pictured in the top left. Just to quickly highlight the variety of neighborhoods, the bottom left image is Leaders High School in Bensonhurst, Brooklyn. The surrounding buildings, as you can see, are 1- and 2-story residential buildings, making the school the tallest building in the neighborhood. By contrast, the West End Secondary School on 61st Street in Manhattan, a picture just to the right of Leaders, is clearly among the shortest structures in the neighborhood. Here's some data from the three sensors we installed at the Washington Heights School, WHEELS. Let me orient you really quickly. The y-axis is showing the level of fine particulate matter in micrograms per meter cubed. And we have a week of days in November on the x-axis. The data points themselves are 10-minute averages. So we have 2 outdoor sensors, one on the roof and another one on the first floor. And they closely follow each other in what I'm calling here magenta and purple, sort of the 2 lines that have the highest peaks. The third sensor, the blue line, is towards the bottom. This is the indoor sensor. And you can see that that line is mostly below the dashed average line. What's really important here is that the purple air sensors are effectively capturing the temporal and spatial variability. And there's a lot of variability. So how do we deal with that variability? Well, one easy thing to do is to take the annual averages, which is what you see here. We got 2010, 15, and 18 as annual averages by neighborhood. The good news on this graph is that the air quality appears to be getting better over time, even in the worst neighborhood in the city, Midtown Manhattan. To provide a little more context, I'm going to show you that the air sensor at the Washington Heights School for the months of October and November. Keep in mind, these are typically low pollution months. This dot is at 6.2 micrograms per meter cubed. We did the indoor one inside the classroom is just under 5. And we also did a reading at a nearby apartment, which gave us a corrected mean of 3.2. I should mention all of these figures are corrected, not the raw data that the purple air sensor spit out. So I'm going to show you now one more thing. I've mentioned variability several times. I'm going to show you the box and whisker plot of the WHEELS outdoor reading. This shows you that the data truly has a wide range, 3.3 to 10.4, with outliers in the hundreds just completely off of the charts here. So what we can see is that the indoor and outdoor air pollution exposure is very different for us. And it's important to remember that even small differences on the y-axis indicate significant differences in health outcomes. The impact of this project is far-reaching. As an example, the students at the WHEELS School are working with We Act in our architecture school to appeal to City Hall and turn 182nd Street into a green street. These are 4 different examples that the students created of what the green street could look like. They're using data from purple air sensors we've installed and the existing purple air network to predict potential changes in air quality based upon changes in traffic. Our recommendation is to create an indoor and outdoor school network of air sensors. As I mentioned before, this would be affordable, and it would serve both the interest of air monitoring as well as providing a teaching learning interface at this unique intersection of public health and environmentalism. In terms of outdoor air quality, little can be done without societal interventions. This is why policy is so vital. For the indoor air, filtration and air exchange is really the key. If there is no filtration, like a lot of buildings in New York City, then we recommend opening the window. So thanks. And with that, I'll leave you on this Zoom meeting that Professor Ben Bostick had with the students at the Wheel School, just to put some faces behind all the effort.